Really excited about today's talk because we've got Karen Herder with us, and she is the head of data strategy at Clarifai. And Karen brings a ton of practical experience when it comes to building these AI-powered solutions, ones that can process unstructured data, images, videos, and texts that people are capturing out there in the world, and building these kind of solutions for businesses so that they can actually create products and solve internal business problems with this kind of technology. For today's agenda, we're going to first take a look at defining model goals and success criteria, defining a taxonomy, obtaining and wrangling data, model training and evaluation, and then model completion. And then we'll finish up by just taking a really quick look at how easy it is to do these kind of tasks in the Clarifai platform. And with that, I'd like to hand the floor over to Karen. Karen, take it away.
Thanks, Jeff. Hi, everyone. As you said, I'm the head of data strategy at Clarifai. So welcome. This graphic right here is an overview of our model creation process. It's a simple visual breakdown of each of the steps in the process, which is pretty much everything we're going to discuss here today. So, what is computer vision? Computer vision is basically teaching computers to see and classify visual content like a human can. My first week at Clarifai, a machine learning engineer gave me some of the best advice for working with computer vision, and I love to share it with everyone, just to not expect a model to see something that a human eye cannot. Think of your computer vision model as a baby who is learning about the entire world for the first time. You're responsible for teaching your baby model everything it needs to know about the world, which you help it understand through defining your taxonomy, your concepts, and your training data. So what exactly is a concept? In the simplest terms, a concept is something that you want your model to provide predictions on, which basically leads us directly to training data, because that's what provides the context for a model to understand each concept. Training data is what the model learns from. It's pretty much impossible to account for every image a model might ever encounter. So the goal of our training data is to be as diverse as possible. We call this creating a whole world view of each concept. So by showing the model as many diverse images as possible, we're teaching it to expect those visual differences within each and every concept. And the first step in creating a model is really important to define your model goals and your success criteria. So first and foremost, what is your model use case? Define it and stick to it. It's important that your model matches the use case you intend to use your model for, because if the training data doesn't match your use case, the model is going to perform poorly because you didn't provide it accurate examples to learn from. Then you need to think about what kind of accuracy is important to you. Do you value precision or recall more than one or the other? Moderation models are an excellent example of precision versus recall from both sides. Some moderation users care more about precision because they want to make sure that their predictions are highly accurate, like they want to get that accurate prediction, but they're okay with letting a few things slip through. So if there's some edge cases that perhaps don't get predicted by the model, they're okay with letting that slip through. But other people using a moderation model may want to make sure that no not safe for work or inappropriate content ever gets on their site. So they care more about recall because they would capture 100% of possibly harmful content. And the give and take with that is that you may risk misclassifying a small percentage of images that are actually safe. And then you need to think about data. Because isn't this where it is all about? Data. Do you have enough data? So this is one of those black box type questions in the field of computer vision. There's no standard minimum amount of data you need to build a model. The data needs will change depending upon many factors, such as use case, taxonomy size, taxonomy complexity, the type of model you end up building, whether that's a context-based classifier or a deep trained model. My favorite guidance to give is a little cliche, but it's really tried and true. Just always add more data. Even if you think you have enough, you could probably use more still. So once you've defined your success criteria, it's time to define our model's taxonomy. And a taxonomy is basically the list of concepts that make up your model. In computer vision, the most important thing to remember when building your taxonomy out is that concepts should be visually distinct. This means that each concept looks obviously different from the other model concepts. So the more visual similarities between any two concepts, the higher chance of confusion between them. When starting from scratch, begin with some good old-fashioned brain dumping, word mapping. It's an exercise that's time-honored for writers and creatives and artists, and it really helps you get in that creative mindset. It takes you down paths you might not have considered before, and it's also a really great way to begin visualizing the natural hierarchy amongst your concepts. Depending upon the subject matter and your familiarity with it, additional research may be required. And then establishing ground truth for each concept is utterly key. In computer vision, ground truth is the mutual understanding of a concept based solely on visual criteria. This is the way that data strategy establishes our ground truth is by creating what we call a visual dictionary. The visual dictionary will define each concept with a wide array of visual examples. I also recommend including a text description just to make sure you're getting your point across, but the visual examples are the most critical. The more nuanced your concepts are, the more visual examples you should provide. Establishing ground truth is going to provide visual confirmation that everyone involved in your project understands the taxonomy and the concepts that make up your model's worldview. And just kind of like an aside from that, is if you do end up later on needing to get data labeled by a team, this visual dictionary will then become your basis for your labeling criteria to share with that team. By providing your labeling team with the plethora of image examples for each concept, it will help them better understand the taxonomy and do a much better job at labeling. So here we have an example of a visual dictionary. It's just part of a small taxonomy that I created for a uniform model project that our Label Force helped label. And you can see that I provided both a text description as well as multiple visual examples. This is kind of the lighter side of visual examples I like to provide. If it was a much more nuanced concept other than perhaps a firefighter or a basketball player, which we all generally kind of know what their uniform looks like, but perhaps it was some more obscure uniform that people haven't heard of so much, or there's many variations, then I would include many more visual examples, because again, it's critical to understand it visually. So I just wanted to take a moment here to walk you through kind of an example of the thought process behind taxonomy development. So for a minute, we're all going to be data strategists, and we're going to put ourselves in that mindset. We're working on building a furniture model to classify your average household furniture items. So considering there's lots of furniture, we need to narrow it down even more. So let's pick one concept, chair. So we've got our chair here. Seems pretty obvious, right? But then we start thinking more into the actual, what is a chair? How many chairs are there? So then you think, how many different kinds of chairs can you think of? How many different kinds of chairs exist that you're unaware of, that you need to do research to find? You can find so many different kinds of chairs out there. It'll blow your mind, and you'll learn a bunch of stuff that you didn't even know existed, probably. Which chairs are so visually similar that they should be combined into one concept? How many different kinds of chairs would a model be able to successfully classify? Is it important that we differentiate between different types of chairs for this model use case? If we create a single concept for chairs, will that work better? How many of these chairs do I need to find training data for in order for our training data to be diverse enough? These are just some of the questions that will be going through your mind when you're thinking about just one concept in your taxonomy. And then you repeat the process again and again for all the other types of furniture until you've completed your taxonomy. So this can be pretty mentally exhausting. Moving on, we're going to talk about obtaining and wrangling our data now. So data strategy at Clarifai obtains data through a variety of means, including scraping, asterisk, when appropriate and legal, I would like to note. We create our own data sets, we use collectors, and we also recycle data from other models. And as mentioned earlier, I just always want to point out, to make sure that your training data will match your model's use case. It's also important to consider how you'll get your data labeled. Is your data labeled? If it is, that's awesome. It's a good start. But I would really advise validating those labels, because even if you have data that is labeled, often it's not labeled correctly depending upon who labeled it. You don't really know, especially if it came from a third party. It's just good to verify that those labels are the ground truth that you are seeking. And then if your data isn't labeled, we need to consider who will be labeling it. Will you label it yourself, or do you have a team? This could depend upon the amount of data that you have. If you have tens of thousands of images to be labeled, you're more than likely going to want to use a team. But conversely, if you only have a couple hundred images, you could probably label it yourself. And then when it comes to creating timelines for data labeling, there's a lot of factors to consider, including how much data needs to be labeled, the complexity of that taxonomy that you're labeling for, if the data contains any inappropriate content, and how long it will take for the team to ramp up to a project while getting used to your labeling criteria. So just some more points to that. If you have a lot of data, obviously it's going to take a longer timeline to get that data labeled. If your data contains inappropriate, not safe for work kind of content, it's important to keep in mind that your labelers will need to take longer and more frequent breaks for mental health, which will increase that timeline. And if the taxonomy is complex or large or nuanced in any way, it can take teams longer to ramp up to feeling comfortable with it. So we've attained our data, and we now need to begin curating it. And usually the first step is cleaning the data from noise. Noisy data is basically the images that don't align with the model use case or taxonomy. In this GIF here, you can see me manually looking through a data set for chairs, and I'm removing images that aren't chairs. The easiest way to begin removing noise from a data set is to use Visual Search and Explorer. Highly recommend this tool, it's fantastic. You can locate large groups of visually similar images for bulk removal. So you see in this GIF where I'm manually selecting a bunch of images that aren't chairs, I could easily have used Visual Search to search any one of these images with those blue backgrounds, and it would group them all together, and then I could bulk delete them all at once. Okay, sorry. Now we've started cleaning and curating our data. I just want to remind everybody to be alert for bias. Bias occurs when the scope of your training data is either too narrow and not diverse enough, but it can also occur due to personal bias. It can affect the model from data collection and onward throughout the labeling and curation process, because basically anytime a human is involved, there's a potential for bias. The best way to prevent biases from appearing in your model is really through just rigor and unrelenting commitment to being independent and unbiased in your conduct. You always have to be mindful of it. Seriously, always be mindful. It's something that I just can't impress enough. So this is a Google search for the word apple. And the results are predominantly red apples. There's a little bit, it's a little more diverse than if you had done this search a year or two ago, but mostly it's red apples. But we know that there are green apples, yellow apples, and so many gradients in between. However, if we just took this data, this red apple data, we built a model and showed our model only red apples, it would assume that all apples were red. And so if we suddenly showed it a yellow or a green apple, it would know what to do with it. It might think it's another kind of fruit. So diversity in your data and avoiding bias and being mindful for bias is just very important. Throughout the data curation process, you're usually going to do some combination of wrangling, cleaning, labeling, or validating data. You also want to remember to set aside an evaluation set, which is a set of images that will not be part of your training data. And it will be used to test your finished model with later after the build process. So it's very important that you set aside those images so they won't be trained into the model. If you train your test set into your model, then obviously you're going to get inflated predictions because it's seen that data before. So after curation, you're ready for model training and evaluation. After we've curated our data, we think we're ready, so we're going to train a V1 and establish a base point. We can evaluate in the platform, and this baseline will give us an understanding of our current model performance and where we need to go from there. Just a quick note, context-based classifiers usually train within a day as long as there's less than 1 million inputs. Deep training, ETA, is more of a black box. It can take a long time depending upon how much data you have. So the page that I'm showing you right now is our versions page in Explorer. And here you can track the different versions of your model and view its evaluation metrics. You can use the evaluation metrics to assess your current model performance and check for weak points. So my absolute favorite tool is the concept matrix. It's an easy visual way to evaluate how your model is performing. It summarizes how successful a model's predictions were by illustrating the correlation between the concepts and the model's classifications of those concepts, or the model's predictions. So a well-built model is going to have this strong diagonal line from left to right, top to bottom, that we're seeing here in this example. Concepts that co-occur or are similar or confused with each other may appear as clusters on the matrix. And here you can see in this example that there is a circled cluster. And this cluster area reveals that the concepts fireplace and living room are occasionally being confused for one another. However, this is the kind of confusion that I'm not very concerned with, because we intuitively know that fireplaces are most commonly found in living rooms. Sure, there are other places too. There can be a bedroom fireplace or an outdoor fireplace, but for the most part, fireplaces are in living rooms. And so much of the fireplace training data that is trained into this model probably also had context around the fireplace that kind of gives it a living room feel. And that's why I'm totally okay with this amount of confusion in my model, because I understand, and I would not be upset if a fireplace was slightly confused for a living room because they have such commonality. If the cluster of confused concepts was something like a hot tub and a bedroom, I would be far more concerned, and that's when I would do a deep dive into my training. So with the evaluation metrics, you can make adjustments to your model and improve performance. You can reshape your taxonomy by adding, subtracting, or combining concepts. Combining concepts is really helpful if you end up realizing that two concepts are just so visually similar that it would make more sense to just combine them rather than to just keep fighting to try to visually push them apart. You can strengthen poor performing concepts with more data, but my advice there would just be careful to not imbalance your concepts. If you have one concept with 100 training inputs and then another concept with 10,000 training inputs, it's going to create bias in your model. So after fine-tuning your model, retraining it, and reiterating on it until you're satisfied with your performance, you're finally ready to use it. And there's just a few things that I would advise keeping in mind after you deploy and start using your new model. The first thing and the most important thing is to be mindful of data drift, depending upon your use case. So data drift, it's also known as model drift, concept drift, model decay. It refers to the degradation of a model's prediction power due to changes in its environment. So in other words, as time goes by, the data your model sees is going to change, but we don't know how much it will change. So we'll need to be on the lookout for those changes and collect new data to refit the model when necessary. An example of this would be social media-based models. Current cultural themes and zeitgeists on social media change rapidly, month to month, 6 months to 6 months. You know, it's an ever-changing culture online, and so your data and your possibly even the concepts you want to predict upon are going to change more frequently than, say, something that is just an established thing, like furniture or uniforms. There's not going to be a lot of data drift for something like that because those are traditional kind of established worlds that we have a lot of data for. That isn't going to change much. And then finally, please just remember, there's no perfect model, but don't beat yourself up for it if you aren't satisfied with your initial results, because you can always improve it. I equate building models to the artistic process. Like artists, painters, sculptors, we never really know when to stop working on our art. We could keep tinkering and picking at it for ages to make it perfect, and we don't really know when to stop. And it's the same thing with the model. It's hard to know. So I just encourage to always know that you can keep refining your model. You can remove concepts, add data, remove data. You can completely change the use case of your model as long as you change the data within it too. Like, there's infinite possibilities. There's no perfect model. No model is going to have 100% accuracy, but it's going to do pretty well if you do these things, if you give it, a solid taxonomy, solid ground truth understanding, etc. Back to you, Jeff.
All right. So let's see how this works. Okay, so as an example, the 4th of July is this weekend. And let's just imagine that you are working with a company that works with user-generated content. And for some very good reason, you realize, oh, hey, it's this weekend is the 4th of July. Let's set up a model where we can route images based on whether or not people are celebrating the 4th of July in a city park or in a national park. And you might use this for some promotional purposes. I'm not exactly sure, but this is the concept. And so let's just see how easy this can be. Now, in terms of building the taxonomy, this is going to be just a very simple toy example. Let's just create two concepts. One would be city park, and then one would be national park. Okay, so just two concepts. And then we've uploaded some data with pictures of parks. And as often happens when you're grabbing some data, you might have done it by a keyword search. And this is a parking garage. This isn't a park, a place where you'd want to celebrate the 4th of July. And so this is noise in the data set. Let's clean this up. This is an example of where visual search can come in handy. So we just click the little search bubble here, and without any pre-configuration, without any thinking at all, it's going to grab images that are visually similar to a parking garage. And you can see that there's really a wide variety of things that it's associating with this image as being similar. And it's just a good, quick way to group things together. Even though this has this car very close up and you'd think it's different shapes, well, it's very different from our images of parks. So what we would do is let's just go through and clean this up. Let's just get this out of our data set as our first step. And we're just going to click these ones that we don't like. We don't need parking garage images. This guy's giving a ticket that's even worse. Cool. I think that might be it. So let's go ahead and just delete those inputs. Quickly cleaning up our data set. Okay, and then, well, let's find our images of city parks. And we can just kind of go through and knock these out. It's fairly easy to tell. They're visually distinct sort of images. City park, city park, city park. Oh, that's a national park. City park, city park. City park, maybe like a royal garden or something. Maybe that's not a city park, but close enough either way. Okay, and we've selected them, and let's just label those as city park. Okay, all done. And then let's go ahead. I'm just going to refresh to get myself back to square one here. Okay, and we see we've got our 18 labels that we just added. It seemed like most of my national park images were down here. Let's add those real quick. Just a quick click of the button. And this is a useful way to work with a small amount of data. But if people don't know about Clarifai's Scribe tool, we have dedicated tools for labeling that are going to be very useful for larger labeling projects, and they can actually use the predictions of our AI models to accelerate the labeling process. Okay, so then we're just going to label these as National Park, good times in the park. And so we've got our labels. Let's just go over to our model mode, and let's create a custom model. This is our new context-based classifier, and we're going to say park classifier, and we're going to select all our concepts. We're going to leave the default settings on everything in this case. We're just going to hit create model. We're going to hit train model, and down here it says models being trained, and model training is 100%. We have a completed model. And then just to get a rough idea of how useful this model is, I mean, this was just a tiny amount of data. This was really a quick way to do things. It's very confident, getting a very confident ROC-OX score, so that this is a very effective model based on the small training data set.